Hey guys, we are here to start our review on states of matter, and we used this in class before, but this is dry ice, and it's carbon dioxide that has been compressed. It's compressed carbon dioxide, so it's actually the same thing that you will see in the air. This is my insane dog. It's actually the same thing that you will see in the air. That comes out of a car tailpipe, that comes out of your crazy dog or your cat when it breathes out, or when it comes out of you when you breathe out. Carbon dioxide is all of those things, and if crazy dog is going to be crazier, she'll have to go away soon. Hi, crazy dog. Oh my gosh. She's still going. Is she going to come around? Here she comes. And here she comes again. And there she goes again. She and the cat like to play. So carbon dioxide is compressed CO2. It's CO2 that's been squeezed together. And carbon dioxide, which is CO2, is normally a gas. But dry ice is called compressed CO2 because it has been squeezed together from a gas to a solid. And here's a piece right here. You can see it is a solid, and it's sublimating. It's not even melting into a liquid. It's going straight from a solid to a gas, because at room temperature it's normally a gas, and you can see that it's turning into a gas right there. So that gas you see coming off of it is the same thing as the compressed CO2, the dry ice. And again, it's just been squeezed together to make it like a solid, even though it wants to be a gas. And so the cool thing with dry ice is that you can see those states of matter, gas and solid, at the same time. I have a glove right here that I'm wearing. It's a padded glove, because if you hold dry ice too long, even for not much more than a very, very short time, it's never a good idea to touch it with your bare hands. It will burn you. It will give you sort of the equivalent of frostbite, because it will really, really quickly cool down the temperature of your skin to a temperature that affects the cells and how they work, and it will give you a burn. So that's why I got the gloves. So we're going to show you a few things with dry ice. I want to show you my materials really quick. I have hot water, I have room temperature water, and I have soapy water, and I have a plastic bag. So here's our first chunk of dry ice. And I want you to notice some of the things that happen to it. I'm going to split it into a few pieces here. Knocked off some pieces. And I want to compare a few things. So first, let's give it in some smaller pieces. I'm going to take a couple of these small pieces, and I am going to put some different temperatures of water on them. And it should make it, as I add heat energy, right? Because this is colder than the water. So when I add the water, I'm putting in heat energy. The atoms are going to move faster. And I want you to compare the different temperatures of water that I put on. So here is water temperature number 1. This is room temperature water. Okay, and you can see that that did speed up the sublimation. There is now more gas coming off of that. But I want to compare that to boiling water. Let's look at our boiling water right here. Right, and you can see how quickly that's creating steam and heat. And actually it's not steam because it's not water, it's creating carbon dioxide gas. And so that will really accelerate the temperature at which it boils. The next thing I wanted to show you is soapy water, just because it's easier to see the gas. You can see the bubbles inside, the gas bubbles inside the water. And so I'm going to put a little bit in some soapy water so you can see what happens. Here we go. And now we've got so much gas you can barely see what's happening. Oh, there we go. Now you can see all those bubbles forming. Those bubbles are the carbon dioxide. And that carbon dioxide gas is getting trapped inside those soap bubbles, which you can actually pick up. And those you can touch with your hand. So they're pretty cool. You pop them, and there's gas inside. It's one of my favorite things to do with dry ice. And this will produce bubbles for quite a while. We'll feed it a little more fuel here. And so long as she doesn't try to touch it, my dog is allowed out here. You can tell that she's got some mixed feelings about this activity. And she gets to continue to participate as long as she has manners and doesn't endanger herself. But you can see those bubbles are getting really big right now. And they won't hurt you. She can touch those. But I don't think she wants to. And again, it's cool because you pop them, and you pop them into gas. It's kind of cool. And we'll feed that a little more in just a second. So I'm gonna go ahead and break off a little more because I've got a few more chunks in here. There we go. All right. And I'm gonna put my phone down while I open this bag up. All right. I got it. So the next thing I want to show you is kind of a proof that you are having that gas take up more space, because I'm going to put some compressed CO2 into this bag, and you'll see that the bag will expand, and that's because gases take up more space than solids. And it's not because there's more matter, it's because those gas particles have more heat energy, and so they are moving around more. And let's go ahead and get a nice piece of that. Just like Chi Chi has lots of energy, she's still running around. And let's stick it in that bag. So one moment, let me get my bag open. All right, so here I've got my bag, and I've stuck some big pieces of compressed CO2 in there. And I'm gonna take my glove off so I can zip it up. And over time, you are going to see that bag expand. And you'll see it actually blow itself up from the size it is now. Although you can actually, if you watch real closely, let's just watch it for a second. You can probably see it growing. And it's actually really full already. This also works really well with balloons, but I like the Ziploc bag so you don't have to tie the balloon, which can be tough with that compressed CO2 on, because it's tough to tie it with a glove, so I recommend plastic bag. All right, you can see it's already expanding that bag, and pretty soon it'll either pop a hole in that bag or the Ziploc will burst. And while we wait for that, let's go back over here. I want you to notice our soap bubbles have stopped, and it's because this has turned into ice. Down here, what you see is no longer actually compressed CO2, it's ice. The compressed CO2 has mostly turned into a gas. You can see there's a little more that's still converting, that's called sublimating. But that compressed CO2 has taken a lot of the heat energy from the water. It's taken the water's heat energy, and it's used that heat energy to turn into a gas. The water is left with less heat energy, which is actually movement. Heat energy is just how much atoms are moving. So really another way to say it is the dry ice has slowed down the water atoms, and as atoms slow down, they turn into a solid. So it's turned those water atoms into a solid, and it's freezing some of that. That's actually mostly ice that you see in there. And that's why you now see less sublimating. You'll see less of that compressed CO2 uncompressing and turning into a gas. As soon as we add more, let me get my glove back on here. You should notice this. As soon as we have more, you'll notice that, again, we're taking heat energy from that water. That heat energy is being transferred into our compressed CO2, which is changing into a gas. Okay. And again, when we say taking heat energy, really we're transferring movement of atoms. So the atoms in the water are moving more than the atoms in the carbon dioxide. The carbon dioxide is taking some of that movement as the substances make contact, and that movement is enough to turn it back into a gas or to make that process go faster. It's already turning into a gas at room temperature, but it's speeding it up. Well, that happens, the water atoms, the water molecules, which are just groups of atoms, those atoms in the water are losing their movement, they're slowing down, and so some of them are now freezing at room temperature, even though they normally wouldn't freeze at room temperature. And again, we can accelerate that with hot water, right? That hot water has lots of movement in the atoms. So really hot water is just water where the atoms are moving quickly. And as soon as we pour that onto here, you will notice that it increases the speed at which we turn it into a gas. We transfer movement energy. And here's what happens, we do a bunch of it. We are putting a lot of movement energy really fast into that compressed CO2, allowing it to turn back into a gas more quickly, because that is what a gas is, atoms that move a lot. And that's why gases fill their container. And I want you to notice this gas filled up its container. It became the shape of this cooler. When it was a solid, it stayed all down at the bottom, right? Because solids don't move very much. They keep their shape. Gases fill the container they're in. Liquids change shape, but they're still pulled down by gravity. So they don't fill a container, they fill a container towards the bottom as they're pulled down by gravity. It's not like a gas where it fills up the whole container. You should have seen that in your videos. And here you got these bubbles. They're a little bit of both. You have that liquidy bubble that's still pulling it down, but some gas. And we've got a big bubble right here. You guys can see my finger for comparison. Let's pop that. You'll see the gas come out. So it's pretty cool. If you want to grab some, it's not too expensive, but it does cost a few dollars a pound. If you do get some, it's fun to play with. Just please do it with an adult. Please do it with gloves, safety equipment, because you really can hurt yourself. Like if you get it in your eye, if you put some in your hand, you won't notice it at first, but it will burn you. So when you're actually touching the carbon dioxide itself, even though these bubbles won't hurt me, because the bubbles are just carbon dioxide gas, which is actually the same thing that you breathe out, so they won't hurt you. Touching it when it's in its compressed form and it has very low heat energy, those atoms aren't moving much, in its solid form, you'll need the gloves. So solid form, you need gloves. Right now I've got some solid forms in here, and if I touch this with my bare hands, it will slow down the atoms in my hand so much that it will cause issues in my body functions, and specifically it will cause a burn. Okay, so you have to be careful with that. All right, so that's it. I think I'm out of hot water, and I only have that one piece of dry ice left. And we will tomorrow review this again when we talk about states of matter and movement. And I think that's all. Bye guys. Bye.